Hi, we are from Iowa State University. We are Team 6 in the IMSD department. We are working with Emerson Automation Solutions. I'm Sarah Mim.
I'm Jonathan Clark.
I'm Joshua Conrad.
And I'm Seth O'Flaherty. And our project is developing an inventory management system for their JAWS for Emerson Automation Solutions machining department.
Emerson Automation Solutions in Marshalltown, Iowa specializes in manufacturing industrial control valves in industries such as food, energy, and nuclear. They use holding devices called jaws to support the machining process. Emerson Automation Solutions was dissatisfied with the lack of inventory management of jaws at their facility. The objectives of our project are to reduce future unnecessary jaw creations by 100%, reduce the amount of unutilized jaws being PMI'd by 80%, and to reduce the time NC programmers search for jaws by 80%.
To design an inventory management system, we started by taking an inventory of all jaws at horizontal CNC NC lathes. After building an inventory, we needed to determine how often each of the jaws was being utilized. To do this, we mined through 4 databases to extract the utilization history of each jaw. By then cross-referencing the history against work orders, we created a report to show which jaws had not been used since 1999. From that report, of the 866 jaws that we inventoried, 436 of the jaws had not been used in the last 18 years.
We then wanted to quantify all the wasted costs associated with those 436 unutilized jaws on the production floor. We then identified the preventative maintenance inspection process, which performs a non-destructive test on every jaw set, results in $58,860 wasted cost every 3 years.
These 436 jaws are red tagged and will stop being PMI'd via the following process.
So the critical portion of the jaw that needs to be covered by the wrapping process are the base grooves right here. This enables the jaw to be connected to the chuck, to the lathe, so that a machining operation can be performed successfully. So the wrapping process is very simple. Just start at the top of the gripping head of the jaw, and then in one motion, wrap all the way around, covering the base grooves, and then finishing again at the top of the head, and then cutting the tape. And then when a machinist needs to use the jaw for an operation, he'll simply cut the tape, and then remove the tape from the jaw, and the cut tape will signal that PMI needs to be performed on this jaw since it was used.
We then wanted to identify all downstream processes negatively affected by the no inventory management system of jaws. We identified that the jaw selection process performed by the NC programming department takes 10 hours longer weekly to perform because of the no inventory management system for the jaws, which requires the NC programmers to physically verify a jaw's location at their respective machines. This results in a wasted cost of $42,000 every 3 years.
Using the inventory we collected, we created a jaw inventory database in Access. We built a user interface to help sort the records. We used 3 tables and a relationship map to increase the query speed. This set of tables included a jaw drawing numbers and bases table, a machine numbers table, and an associative table to relate the jaws, bases, and machine numbers. We designed the UI with the knowledge that NC programmers would be the primary users of this database, followed by tooling engineers. The user interface was designed so the fields that were most likely to be searched were at the top.
This design will eliminate the verification step for the NC programmers and add an auditing step preventing wasted jaws being made. The economic impact of this project was $92,514. This is a 124% return on investment.